Okay, this is page 4 now. We are on number 15 to start off with. So number 15, IQ test scores are normally distributed with a mean of 100, a standard deviation of 15. Find the IQ score that corresponds to a z-score of 1.96. So here's what we're given. We're given the mean is 100. So remember that is our mu symbol. We're given that the standard deviation is 15, so that's our sigma symbol. And of course our z-score is 1.96, which of course we can just plug that in for our z value. So these three things are what we know, and we are asked to find the IQ score. Well, that's going to be our x value. So we want to find x. Okay, we have a formula to find x. X equals z times sigma plus mu. All they did, they reworked the z-score formula to now solve for x. Okay, so plugging in what we know the z-score is 1.96. Our sigma is 15. Plus our mu is 100. We can put all this in our calculator one step, and we would get that x equals 129.4. So that is our IQ value that's associated with that z-score of 1.96. So it looks like that is answer choice B. Okay, so another formula right there. It should, again, be provided for you, but again, it doesn't hurt to know that formula and the formula to calculate the z-score. Okay, next one, number 16. An airline knows from experience that the distribution of the number of suitcases that get lost each week on a certain route is approximately normal, with mu equals 15.5 and sigma equals 3.6, so the mean and standard deviation. In 1 year, how many weeks would you expect the airline to lose between 10 and 20 suitcases? Okay, so let's think about what we have. We have mu, we have sigma, and then these two values, 10 and 20. So are those x values or z values? It doesn't say z-scores anywhere in this one, so these are actually x values. So I'm going to label them x1 and x2. So since we have two values, we need to go ahead and change these over to z-scores so we can actually do stuff with them. So our first z-scores, so remember z equals our x minus mu divided by sigma. So plugging in x1, we would have 10 minus 15.5 over 3.6. And I'm going to go ahead and write out what our second one would be also. X minus mu divided by sigma. So 20 minus 15.5 over 3.6. So let's get out our calculators and calculate what we'd get. 10 minus 15.5, and then divide that by 3.6, and we would get negative, wrong color, 1.53. And then when we plug in 20 minus 15.5 divided by 3.6, we get a positive 1.25. Okay, so now we have the z-scores. We want to find out how many weeks would you expect roughly. So one thing we need to do, we need to go ahead and think about what is our z-score, not z-score, what is our probability of losing between 10 and 20 a week. So we have negative 1.53, and then we have positive 1.25. So between those two z-scores, so we know z-scores and we want to find the probability. So then we go ahead and but in our calculators with our normal CDF, we have our lower bound is negative 1.53. Upper bound is 1.25. So this would give us our probability of losing between 10 and 20 suitcases in a week. And we would get that the probability is between negative 1.53, which is less than z, which is less than 1.25, equals, remember probability, round it to 4 decimal places, so 0.8313. Now then that just tells us the probability, okay? The question is asking us how many weeks in a year would we expect to lose between 10 and 20 suitcases. So we know that we have a probability of 83.13% or 0.8313 if we left it as the decimal like we have it. So this is in 1 week, so we need to see how many weeks out of a year. So we go ahead and we take our, I'm going to move this on up here, 0.8313, and we multiply it by 52 because there's 52 weeks in a year, and we would get that this is roughly 43.2, in which, since it says roughly, we can go ahead and our answer would be about 43 weeks. Okay, so again on that one we had to find out, going back to our percentage, finding out how many weeks would we actually lose, or could we actually lose between 10 and 20 suitcases. Okay, now on to 17. 17, find the z-score that corresponds to the given area under the standard normal curve. So this time we're given the area, we got to find the z-score, so now this is the opposite. So we're still able to use our calculators, but now instead of using normal CDF, now we are going to use that lovely inverse norm. So inverse norm, and then we go ahead and we place what our area is. So the area for this one is 0.2810. We press enter, and we would get that our z-score is negative 0.58. In which I think that one, oh, no answer, or no multiple choice on this one, okay? And again, looking at what our picture looks like, we do know it's gonna be on the negative side, and it's pretty close to 0, so negative 0.58 does make sense for this question. Okay, next one, find the z-scores for which 90% of the distribution's area lies between negative z and positive z. Okay, 90%. So again, let's go ahead and start off with always drawing a visual. So visualizing lies between, oh look, there's negative z and positive z. So between these two. And again, it doesn't have to be perfect for you visually, okay? 90% lies between here. Whew, that's a lot. But anytime we want to find z-scores using our calculators, we have to know an area that is to the left of a z-score. So an area to the left of our negative z, well, we don't know how much is over there right off the bat. And then the area to the left of the positive z, well, we know a lot of it, but again, we're missing that little piece right there. So remember, underneath our bell curve is 100%. We have 90% in the middle. And since this is a normal, it's symmetric. So that means that this side and this side are the same area. So 100 minus 90 equals 10% left over. And then we have to divide that by 2 because we have 2 even pieces. So that means that each side is 5%. So that gets us that whole 90, or sorry, that whole 100, not 90, I was looking at that. Okay, so now that we know the area to the left of a z-score, whenever we plug in an area, it always needs to be as a decimal. So this is going to be 0.05. So we'll go to our inverse norm, 0.05. That will give us a z-score of negative 1.645, and you'll notice on this question it is multiple choice, and it actually has these z-scores. The closest one has 3 decimal places, so on this, just be sure you match up which one is the correct answer. So if this z-score is negative 1.645, these are symmetric again, so that means this number is even the z-score on the other side, and that would be 1.645 as the positive, okay? And so then that means that our answer choice is D. Okay, and if you wanted to find that bottom one, it's inverse norm, let's see, 95, so 0.95 would get us that one. Okay, so you could work it out that way as well. But again, they're symmetric, so they are the same. Okay, last one for page 4. We are on number 19. Use a standard normal table to find the z-score that corresponds to the 80th percentile. So whenever we see the word percentile, all that is telling us how much information, whatever we're looking at, is to the left or below that one spot, okay? So drawing our bell curve, again, for our visual, 80% is to the left of it. So that means we have all of this is 80%. Okay, so we are looking for our z-score. We know the area. So we go to our inverse norm. And our area is 0.8. And so using our calculators, we would get 0.842. And again, this is a z-score, so 0.84. In which, that looks like answer choice A. 0.84. Okay, that was page 4.